Okay, so our problem for today, which is a system equations with business applications, is Tiger Woods is planning a new line of golf shirts. For the first year, the fixed cost for setting up the production line is $14,000. The variable cost for each shirt is $18. The revenue from each shirt will be $29. Okay, so for the first problem A, you're going to find the cost function. So this is going to be your problem, how much it costs you to start your business. So you're going to have your cost function is going to equal your fixed cost plus your variable cost, which is the cost to make a shirt. So your fixed cost plus your variable cost. Okay, and then so for second step, it's going to be C of X, which also means the cost function, equals 14,000, which is your fixed cost, plus 18x, because every shirt you make is going to be $18. So for problem B, you're going to find the revenue function. So you have revenue function equals price of items sold, which was $29. So you have revenue function equals price of items sold. So you have R of X, which also equals revenue function times price of items sold, which is 29, and then times X, because that's however many shirts you sell, you're going to multiply by 29. So for C, you're going to find the profit function. So you have profit function equals the cost to make a shirt times X plus the fixed cost, so it's like the cost function, and then you subtract the revenue function, which leads you to get your profit. So you have just like this, profit function equals parentheses cost to make the shirt times X plus your fixed cost subtracted by the price of item that you sell. And of course times X, that's how many shirts you sell. Okay, so it's just written out like this. P of X equals 18X plus 14,000. So variable cost, fixed cost, minus 29X, which is your revenue function. Okay, so for an example, we're going to do if you get a profit or loss from selling 1,000 shirts. So simply all you're going to do is plug it into your profit function. So you have P of X equals 18 times 1,000 plus 14,000 minus 29 times 1,000. Just going to work that out. You get P of X equals 18,000 plus 14,000. Don't forget to put that in parentheses. Do it first. Minus 29,000. So now you have P of X equals 32,000 minus 29,000. So remember, on this side you have how much money you made. So you made 29,000, but it cost you 32,000 to make that. So you have $3,000 in loss. Okay, so finally for E, we're going to do the break-even point, which means how much money or how many shirts you have to sell to break even to get exactly even. So in this instance, for E1, we're going to do how many shirts it takes to break even. So we're going to get our profit function, P of X equals 18X plus 14,000 minus 29X, just like we did in D. And then, so for that, you're just going to set it equal to each other. So you're going to get rid of the P of X. And then you're going to set them on separate sides. So 18X plus 14,000 equals 29X, right? So then what you're going to do is you're going to subtract 18X, combine like terms. You're going to have 14,000 equals 11X. You divide by 11, and for your final answer, you get X equals 1,272.7, but of course that you can't sell 1,272.7 shirts, so X is going to equal 1,273 shirts. So that's going to be your final answer for you to break even. So then we're going to do E2, which is determine the amount of money you'd have to make to break even. So we're just going to get our revenue. Revenue function equals 29X, just like we did up in problem B. And then we're just going to plug in, using your revenue function and substitution, the number of shirts from problem E1. So we had 1,273 shirts. We're just going to plug it in. So we have R of X equals 29 times 1,273. And the amount of money in your final answer is going to be R of X equals $36,917. Okay, so this is how many shirts you need to break even to sell, and this is how much money you need to make in order to break even.